All right, let's just take an extremely quick look at the quantum mechanical model of the atom, which we'll explore a little bit later on. But let's just state off why it's necessary. So the Bohr model is pretty good, but it's not quite close enough to the truth. It's not quite accurate enough. So it's, we'll say, but not always good enough. And so we need a more accurate model to be able to predict more complex quantum phenomenon. And so some of the main things that basically the Bohr model breaks apart at is we can't actually tell where an electron is. And that's a wave property. So think about, when we talked about light as a wave or an ocean wave, it's not really in one place, it's throughout the whole structure. Same thing with an electron. We can't really quite tell where it is. We can only tell where it probably is. So we can get like a rough estimate. The electron's probably somewhere in here, but we can't tell exactly where it's at. That's called the Heisenberg uncertainty principle. And if you take 101 or higher levels of chemistry, you'll get more in depth. Again, we're just doing an intro to chemistry, so we're just gonna skim the surface of a lot of these topics. And then the other thing is that these orbitals that we drew as these circles, and so that's where these electrons are, they aren't always circles or spheres. They've actually got more complex shape to them. And so I've got a little image here for you, and we'll explore some of these weirdly shaped orbitals, but not necessarily all of them, right? So these are the orbitals for electrons, or for electrons in the hydrogen atom. So this kind of predicts where the hydrogen is. And at the center of each one of these would be the nucleus. So you can tell in this kind of top two rows, these ones look just like our Bohr model, right? They look like spheres or circles. But as you can see, when we get to other orbitals, they get a little bit more funky looking. And again, this has to do with the complex wave nature of our electron. We'll explore some of these orbitals here shortly.